So this session is going to be about the alarms. The agenda is going to be this one. First, we are going to define what the alarms are in that data hub, then how we can set up the alarms, how you can choose the type of alarms and the types of settings that you need to put in motion to get that working in data hub, how to set up the notifications and what kind of notifications you can set up in data hub for the alarms. And how you can manage exceptions for alarms in Data Hub, and then a short review of the alarm templates and the API. So first, what are alarms? Alarms are actually quite simple to understand. They are events that allow users to be notified when data points or predefined calculations from data points, for example, go above or below a specified threshold. So basically, those alarms have been available for a while through the API in Data Hub already. So you may have been using them for a while. In our roadmap, we have a UI user interface that is being refined as we speak, and will be made available before the end of this year. So I'm going to show you a preview of this user interface today, but it's not available right now in Data Hub. Also, the features that are currently present in the product are going to be refined based on the current use that we can see, and also on future user case. So what are the alarms in details? They are characterized by a few properties. First, there's an alarm type, which is a threshold or binary-based alarm. So basically, do I have a floating threshold or a binary state, which is going to trigger the alarm? I have an alarm type, which is a threshold type, which is going to be high or low. So do I want to trigger on high or low values? We can have set and reset thresholds. We will see for binaries. It's going to be 0 and 1s, of course. A frequency type, which are raw, rolling, and scheduled. We will see that later on. And an alarm is characterized by a state. We will see also later that we can actually customize alarm templates to apply on many different sources and variables at the same time. You have a screenshot of the UI, but you will show it. We'll show it in details later on. You may know that there is already a feature in Data Hub which is available and which is called the alerts. So the alerts and alarms share a number of features, but the alarms go further into that features. The first difference between the alerts and the alarms is that the alerts can use only one threshold, which in the alarms is different because there are two thresholds, and the alerts are generated every time the threshold is exceeded. So every time you go above or below your set value, an alert will be sent and notified. This is not the case with alarms. We will see that later. Alerts cannot be reset, whereas alarms can be reset. Alerts cannot be acknowledged. There are exceptions in alerts, but they are only schedule-based and not also variable-based, as the alarms can be. And you cannot make templates for alerts. So those are the main points and differences between the alerts features and the alarms features. An alarm is also characterized by states. So there are a few states that you can have for alarms right now in the product. The first one is uncertain, and it is the first state that you will have on initialization. So this includes when you disable and re-enable an alarm, the state of the alarm will be reset to uncertain, because we don't know what the state of the alarm is at the current state at that time. You can have an inhibited status, which is when the alarm is disabled. You have two main states, which are the usual states for alarms, which are present and not present. So present is when the set threshold is crossed, and not present is when the reset threshold is crossed. And last, you have the acknowledged state, which is set manually by your user after receipt of a notification. If an alarm is in present or not present state, then you have the possibility to acknowledge that you have seen and received the alarm. Also important to know, the first data point or value that you receive on which an alarm is set will and which crosses a threshold, either set or reset, will set the first present or not present state of the alarm. We will see that with an example later on, so don't worry. This will be easier to understand. So how you can set up the alarms? Well, first, I was talking about alarm types. There are two types for alarms. First one is the threshold type, which will use float values. So basically, you're going to be using the values in the same unit as the monitored variable on which you can set up the alarm. And it can also be of binary type, in which case you have a 0 or 1 state. So either the set or reset states will be 0 or 1. The alarm is also characterized by its threshold types. You have a high type or a low type. High type means we are going to cross a set value, and we are going to look for values which are higher than the set value. And for binary types, it's going to be equal to 1. And for the low threshold type, we're going to monitor values lower than the set threshold. In binary terms, it's going to be values equal to 0. The thresholds set and reset are going to be expressed as a table, because you can, of course, set up high or low types, in which case, as you can see on the table, if you are using binary type alarms, if you set up your alarm as a high type alarm, then the alarm will be notified when the value equals 1. So the set value is going to be 1, and the reset value is going to be 0. So the alarm will be reset when the value is 0. If you set up to be 0, and the reset value is going to be 1. So the alarm will be present when the value is 0, is the set value 0. For the threshold type, this is going to be the same principle, except that it's not going to be 0 or 1. It's going to be a value of X or Y. So, for example, 100 kilowatts for the set value, and 50 kilowatts for the reset value if you're a high type. So you're looking at values higher than 100 kilowatts. This is going to be seen in diagrams after, and of course a demo. Last, before I go into the details of and some examples, is a frequency type. So you have the possibility to have 3 different frequency types. The first one is a row type, in which you're looking for instantaneous values. So I'm looking at the value right at the time when I'm looking at it, without any sort of aggregation. You have the rolling type frequency type, which is going to be an aggregation of the value on a period, including the data point. So I'm looking at, for example, the average value on the past hour, on the past day, and this value is going to trigger or not the alarm. And last is the scheduled frequency type, which means we're going to aggregate value on a period of time in a specific time window. So I'm going to go into 2 examples in the slides now, and then I'm going to show you the interface. The first example is going to be an example for a row type alarm on threshold with a high type of alarm. So we are going to look at an alarm at a value which is going to be higher than the set value in a row frequency type, meaning we're not doing any type of aggregation, we're just looking at the value. So you can see on the diagram, I have my set and reset levels. The set level is higher than the reset level, of course, because this is a high type. And I'm receiving data points. So the first data point is, in this case, below the reset threshold, meaning it's going to set the first state of the alarm to reset. Okay, so the first data point in this case sets the alarm to reset state. Then I'm receiving now a second data point, which is above the set threshold. In this case, the alarm type, state is going to be present because it is higher than the set threshold. And then I'm receiving more data points. As long as they're not above the set threshold or below the reset threshold, they do not trigger any change of state for the alarm. The slight value that you can see here is below the reset threshold, so it sets the state of the alarm to not present again. And then as we're receiving more data points, you can see the pattern now. We're not changing until we have a value above, for example, here, the set threshold, in which case the alarm state is again present. Okay, so this is a quite simple case. Another example is for the binary, and in this case, we're going to look at a low type alarm. In this case, since it's a low type alarm, the set threshold is 0 and the reset threshold is 1. And the principle is exactly the same. So you receive a first data point, which is 0, which sets the first state of the alarm to present. And then you receive another one, which is 1, which sets the state of the alarm to not present. And then you're receiving more data points. And of course, unless there is a change, in this case, it goes back to 0, the alarm state does not change. So here it's back to set to present, and then it will change when you receive the next data point in the reset state. Okay. So let's look at how it looks in the product in Data Hub. So as you can see now, we are in Data Hub, and this is the first look of this user interface that I was talking about before. This is the screen that is not available in the product right now, which is going to be ready before the end of this year, as I was telling you about before. You can see here that you have a list of alarms that I have already set up. So let's look in details in how we can set up an alarm. So let's take this one as an example. Of course. Okay, so my alarm here, which is called Opinum Win Output 2909. So that's my personal name here for this alarm. Has been set up with a frequency type of row. So in the interface right now, we have only row and rolling types, frequency types. The schedule type is only available for now through the API. So don't worry, it's going to be available when we release this feature as well. But for now, if you want to set up a scheduled frequency type alarm, you have to go through the API. When you set up an alarm, you have to pick a site, a source, and a variable on which you put the alarm. So they were chosen before. And then you can choose and change the alarm type as you want between threshold and binary. Also, the threshold type is going to be low or high, as we talked about before. In this case, it's going to be low, so I'm looking for values which are going to be below 200 kilowatts. And the reset value is going to be when the value goes again above 800 kilowatts. I will talk about notifications, exception, and all this stuff afterwards. So let's just start with that for now. When you first define an alarm, it's going to be in a state in disable stages. So don't forget to enable it if you want it to be triggered, of course. This is how you set up very easily an alarm in the interface. We'll get back to that afterwards. So let's go back to the presentation. I will talk about the other example that we can have. The first one, well, the third one is a rolling type alarm. A rolling type alarm is doing an aggregation. In this case, we have an example with a rolling type which is doing a sum on the past hour. So you can see on the diagram, the green values are the instantaneous row values, and the brown values are the aggregated summed values on the past hour. I have here an example with an alarm which is set at 100 for the set value and a reset value of 50. So as you can see, the first value at 20 here, since it's below the reset value, will be set will set the status of the alarm to reset. And then as you go along with the values, you can see that the aggregated value does not go above the set value, so there's no change in the state of the alarm. When we reach this state here at 10:30, the aggregated value is 110. So since this value is higher than 100, the alarm is in a present state. And we go along, as you can see, the value goes above that value, but does not go below the reset value, so there's not a change of state for the alarm until 11:15, when the aggregated value goes below 50, in this case 46, so the state of the alarm is not present again. A fourth example here is the same type of rolling alarm, but with a low type alarm and a different type of aggregation. Here we have an aggregation on the minimum value over the past day. The principle is exactly the same. The aggregated value here is since it's not below the set threshold nor above the reset threshold, there's no change of alarm state before the 3rd of March 21, 10:30, which means if you don't have a previous state of the alarm, it's going to be in an uncertain state until you reach the 3rd of March, in which case you go above the reset value, so the alarm state is going to be not present in this case. And as you go along, the state changes only on the 5th of March, where the minimum value, aggregated value over the past day is going to be 5, so below the 10 set threshold. Last example is a scheduled type of alarm. In this case, we're going to look at the sum of the value every hour, but we're only going to look at the past hour based on each passing hour in the day. So at 10, I'm going to evaluate the values, the aggregated summed value over the past hour. It's going to be 20 here in this case. So since it's below the reset value, the state of the alarm is set to not present. The next hour, the aggregated value is 90, so it's not crossing any set or reset thresholds, so the alarm state is not changed. When I go to the next hour, at noon, we can see that the aggregated value is 150, so it's above the set value. In this case, the state of the alarm changes to present. And the hour after, we go back below the reset value, so the state is going to not present again. So you have seen in those examples different types of values and configuration in which you can configure the ways the alarms are going to be notified depending on the type of data you have and the kind of alarms you want to set up for your data points. And in the next slide, I'm going to talk about the notification types. You have 5 different notification types for the alarms. The first one is you can be notified by email. You can be notified by SMS through a webhook if you have defined the webhook before, of course. You can have a notification through an event on a specific site, so the site to which the variable and the source are linked, of course. And you can also store the result of the alarm states in a variable. The variable must already exist when you set up your notification, if you want to do that, and it has to be in the same source as the one you monitor for alarms. And the variable will contain zeros for the not present state and ones for the present state. The list of states here are the ones that you can link to the different types of notifications. For example, if you want to set up a variable type notification, you can link set, reset, set and reset states, and also the acknowledged states to your variable. The next thing is you can also manage exceptions in alarms. So let's say you have a solar farm, you are producing electricity through the sun, and you want to manage alarms on the output of your productions. Of course, when it's during nighttime, you don't want to do that because you expect that you don't have any production. That's one example. So exceptions are managed exactly for that. There are 2 types of exceptions that you can set up. The first one is a schedule-based exception, and the other one is a variable type exception. Schedule type exception existed already for the alerts. The variable type is a new one for the alarms, and it allows you to use the value within a variable as a condition for an exception for the notification of your alarm. Let's take 2 examples, but just to say that the status of the alarm is not going to be evaluated during the exception periods. That means that even if it goes back to a reset or a set to present or not present state during those exception periods, you're not going to get any evaluation of those during the exception periods. So let's take an example of a schedule-based exception. In this case, you have you can see the different data points. The first one here has a change of state, and we have set up a schedule between the point A and B, during which we have an exception. So you can see the theoretical changes of states of the data points during that time, but those are completely ignored. And the next change that you will have for your alarm is when it goes back to 0 at the end of the timeline you can see here. We don't have any new evaluation in between. The second one is a variable-based exception. In this case, we have in black the variable in which we put the alarm, and in cyan the variable in that it's used as an exception criteria. So the first change of state here is the first one at the beginning of the timeline. Then you have a change to 0 on the second point, and then when it goes back to 1 here, well, since we put a condition that the variable here should be higher than 0 to have the exception, we do not evaluate the change of state here for the monitored variable. The next one is going to be here at the end of the timeline when the variable that is used as a condition goes back to 0 or below. So I'm going to show you an example now in Data Hub, very simply. So going back here. So let's get back to our alarm here. If we look at this alarm I set up earlier, for this one, I did not put any exceptions, but this is where you would put an exception here. I have another alarm here, for example, that has an exception. For example, here, this is an alarm that has been put on a wind farm, and I'm going to ignore any values of my monitored variable if another variable, that is the wind speed in this case, is higher than 200 meter per second. The idea would be for this example, if you have a safety state for your wind turbine, if the wind is too high, then you would just have a shut off of your turbine, and then you don't want to have an alarm in this case, because you know it's normal, it's the state that you're expecting. Let's just look at it. I have here set up a site. So let's say we at Opinum have a wind turbine, and we are going to monitor it. So if I look at it, I have already input some data points here, and I'm going to just simulate again the acquisition of the data point. In blue, you have the output power of my wind turbine, and in green, you have the wind speed that is monitored at the same time. So I'm going just to upload again just the value just for the demonstration here. Okay. What I'm doing here is just re-upload the values of those data points here and wait for the system to generate alarms again. So for this alarm, going back to there and while it's processing it, I set up different notifications. I have set up two notifications. Sorry. One is of an event type when it sets and resets the states. So this is going to create site events for that variable. And I have also chosen to add a notification which is going to be stored in another variable. So it's going to be stored in a variable that exists on the same source. In this case, alarm allow power output, again for the set and reset states. So let's get back to our system here. It's processing again. So let's just get back here to our state. It's being processed as we speak, so I'm just waiting for it to be ready. I have already the events that have been notified, so you can see that we have 4 different events. Each event is going to express the name of the alarm, the source on which it has been notified, as well as the site, and what is the status, set or reset, or rather the limit that has been crossed, and at what time. Also, you have the value of the variable at the time that it has been notified. So in this case, you have 4 different events that have been generated. And if we go back to the dashboards here, we should be seeing the variable as well. If it can go. This is demo effect. There it is. So you can see here, for this one, I have my values here. And as long as we don't go below the 200 kilowatts, we don't have an alarm. Here you can see that we have a value below 200 kilowatts, 22 in this case. So the alarm goes to 1. And it will only reset when we go above 800, which is going to be somewhere here. So there's a 0 state here that is stored. And then it goes back again to present when I go below again the 200 kilowatts, which is here. Okay, so this is the first one. I have set up another one at the same time, which is exactly the same as the other one, except I have put an exception, as we said before, on the wind speed, which is higher than 200 meter per second. In this case, it's being stored in another variable here. So we expect that we don't receive any change of state for this alarm if the wind goes above 200 meter per second when we have an alarm state, a present alarm state. So you can see here that since for those two types of states of alarms, since at that time the wind was higher than 200 meter per second, we don't receive any change of states for this alarm actually. Okay, I'm going to try and wrap up this session with a few more notes. The first one is the alarm templates. So alarm templates are going to be used on source views and will be applicable on all the variables with the same name that you have on all those sources. So of course it's targeted at sources and variable with similar patterns. It does not make sense if you are using templates for different types of variables, of course. So in the interface, it is located here. In the same screen as the alarms, you have a button here for alarm templates. And you simply pick a template name, a template ID, okay, a frequency type that will be shared with all the alarms, and you pick a source view, in which case we will retrieve all the variables that are on the sources in this view, and we will present a list of variables on which you can set up the alarms. The number between brackets is the number of variables that it can find in this view with the same name. So say I want to put a template on the power output. I'm going to put a threshold, an alarm type threshold with a low value again, with the same numbers I put before. And what it's going to do, if I do that, it is going to look at all the variables it can find with the name power output, and it will offer you to create an alarm on the 4, in this case, variables that were present in the view. So in this case, you just batch create the alarms on the whole view that you have selected. And of course, you can filter then on the alarms that are based on the same template. You can see here it's filtered on the test template I just created. So it's very easy to find them back. Okay. A few last words on the API. So George told you about the API before. It's been present for a while, as I said, and it's available right now. So if you want to use it, you're welcome to use it. The API is available, and you can find the computations through Swagger on our own Swagger that you probably know. So let me show it to you so you can see it. So if you go to Swagger, you have all the calls here that you can make on the endpoint for the alarm. Well, if you're familiar with that, it's going to be quite easy to find what you need to set up to configure the alarms. Again, this is already available, so we're available to help if you need, but don't hesitate to try and see what you can do with those alarms through the API until you can get that through the interface before the end of this year. So that's it for now for this session. If there are any questions that you would like to ask, feel free to do so now. Okay, I have a question here from. Oh, thank you, Matthew, for first. From Nicola, I have a question, which is what were the primary use cases used to define the specifications. We actually worked with two specific customers on these features, and this was primarily for the monitoring of the consumption of energy that we try to set up those features. Sorry. So of course, as I mentioned early in the presentation, we are going to refine those based on more use cases that we will meet, or we have seen already some use cases in which we could, for which we could refine the specifications. Are there any other questions, or is that okay for? Do you need more details on this question? Okay. Well, I'm not sure I can already divulge what kind of new features, but we are looking at probably improving the kind of alarms we could set up, and then we are looking at working with our customers to develop those features. So you're very welcome to give your input if you want. That would be very appreciated, of course. Yes, thank you, Vincent. So Vincent was just mentioning that once an alarm template exists, any source that is created and matches the view will automatically get the alarm, meaning the alarm will be set automatically on that new source in which matches the view. So it's quite powerful because you don't need to reset up your alarms continuously. Thank you, Vincent. Any other questions? Nope. Then I think we will close this session. Thank you for attending this session, and I think we have a short break for now. So you're welcome to come back at 1 p.m. for the next session. Thank you for following this session, and well, have a nice lunch.